Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn some more about combinations and permutations. All right, a combination is a set of individuals chosen from some group in which the order of selection doesn't matter. The notation NCR represents the number of different combinations of R individuals chosen from an entire group of N individuals. When we're calculating combinations, you can calculate the number of combinations of n individuals taken r at a time, where r is less than or equal to n, using the multiplication counting principle, or with this formula. So NCR is equal to NPR over r factorial, which is n factorial over r factorial times n minus 1 factorial. All right, an example. Mr. Starnes loves ice cream. The local ice cream stand offers a triple scoop dish of ice cream. The stand has 15 different ice cream flavors, and Mr. Starnes always chooses 3 different flavors for his dish. How many different sets of 3 flavors can Mr. Starnes choose for his dish? All right, so we're going to say that the order that he picks the ice creams doesn't matter because they're just kind of going in a dish or a bowl. So there's 15, and he's going to choose 3 different flavors. So 15 choose 3 would be the same as 15 pick 3, they're permutations, over 3 factorial, the total number of options. So he could do 15 times 14 times 3 over 3 times 2 times 1, which is 455. And in our calculator, remember, we can go to math, go over to probability, and you'll see NCR, or you can also do alpha y equals, and then go to functions, and you'll see NCR. So there are 455 different sets of 3 flavors that Mr. Starnes can choose. All right, another example from counting to probability. Your school cafeteria has purchased enough food for 12 different lunches over the next few weeks, 5 of which include some sort of pasta. Due to a holiday on Monday, there are only 4 school days this week. The cafeteria workers plan to randomly select 4 different lunches from the 12 lunches to serve this week. What is the probability that all 4 meals this week will include pasta? All right, so I want to find the probability that all 4 lunches include pasta. So I want to need to know the number of ways to choose 4 pasta lunches out of 5. There's 5 total lunches that include pasta, so 4 out of 5. Divided by the total number of ways to choose 4 lunches from all the choices. Okay, so this would be 5 choose 4, because there's 5 pasta choices, and I'm going to choose 4 of them, divided by there's 12 total choices, and I'm going to choose 4 of them. So the top part would be 5 times 4 times 3 times 2 over 4 times 3 times 2 times 1. And then the bottom part would be 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1, which ends up giving me 5 over 495, or 0.010. So there's about a 1% chance of all 4 being randomly selected that include pasta. Finding the probabilities with combinations. The student council at a local high school consists of 10 juniors and 30 seniors who are advised by the teacher. The State Association of Student Councils is holding a conference, and the school has enough funds to send only 6 students. The student council advisor decided that 6 students would be selected at random to go to the conference. The advisor conducted a drawing one night after school and announced the results the next day. 4 juniors and 2 seniors would go. The seniors were concerned that the advisor may not have used random chance to decide because so few seniors were chosen. How many possible groups of 6 students can be selected? So there were 10 juniors and 30 seniors, so there's 40 total students. So how many possible groups of 6 students out of all of the students would be 40 choose 6, which works out to be 3,838,380. Part B, find the number of ways in which a randomly chosen group of 6 student council members could result in 4 juniors and 2 seniors being selected. All right, so this would be 4 juniors. Well, there was 10 juniors, so 10 choose 4. And 2 seniors. Well, there was 30 seniors, so 30 choose 2. And means to multiply them. So if I did the work out, it would look like this. So it's 210 times 435, which equals 91,350. So find the probability that random selection would result in 4 juniors and 2 seniors being chosen for the conference. So I'm going to do the probability of 4 juniors and 2 seniors by chance, which is the part we found in Part B, divided by, or the number of ways to get 4 juniors and 2 seniors, divided by the total number of ways to get 6 students. So we have 10 choose 4 times 30 choose 2, which is what we did in Part B, over 40 choose 6, which is what we did in Part A. And we end up with approximately 0.024 or 2.4%. The probability that 2 or fewer seniors would be chosen is 0.0258. Is there convincing evidence that the selection process wasn't carried out by random chance? Explain your answer. So we're going to say, because it is unlikely to select 2 or fewer seniors by chance alone, there is convincing evidence that the selection process wasn't carried out by random chance. All right, we would expect it to be like 5% or higher if it was fair. But because there's a very little chance, then we don't think that it happened purely by chance, that there was maybe some other things going on. All right, go Seahawks.